What's the value? Okay, so we're now trying to relate more application rather than just using the equations that you have. Okay, so we have here a shaft and then you have that torque caused by that power. Normally, you have this equation, power is equal to torque multiplied by the omega. So this omega will be based on the rotation revolutions per minute. So your machine or your motor will be rated according to its speed. So it's not in radians per second, but in RPM. That's the common rating that you have. That's reality. So your manufacturer won't say, oh, your rotation, or this will be rated in radians per second. It will say it's in RPM. So the question is, if you're going to look at or sizing a so-called shaft, so you need to know your power as well as that RPM rating. So how do you solve for that? So you have now here, given power equal to torque multiplied by omega. Yes? We have the power, which is in megawatts, and we have omega here. So let's have a look. Torque is equal to the power all over omega. This one now will be 1 megawatt. Okay, so 1,000 watts. Okay, your omega is equal to a value in radians per second. Okay, so this one is 1 million watts. Okay, thank you. Now moving on, you have now here 5,000 revolutions per minute. Check the units. Okay, watt is joule per second. Joule is Newton meter per second. So you have to convert this one. This should be unitless and this will be in seconds. So what will be our conversion? So we multiply this one with 2 pi radians, so unitless now. So I can just remove that per revolution. Okay? And then that's a minute, so I multiply this one with 1 minute all over 60 seconds. Yeah? So minute cancels out, revolution cancels out. I have now a Newton meter second all over 1 over second that goes up, so your second cancels out. Yes? So you have now your torque in Newton meter. 1909. So this will be in Newton meter. So that will be your torque. Okay. Going now to your stress. So what about your shear stress? This will be Tc all over J. We know that C will be half the diameter or the radius. So this will be T is the diameter given. Yes. Well, C will be the outer diameter. C will be outer diameter divided by 2. So that will be the outer diameter divided by 2. And your J is given. So this now will be 1 all over 32 pi DO. I think there's a mistake here. DO cube. Sorry. So DC all over J to the 4th. Okay. Pi all over 32. Yes, sorry for that. Anyway, this one is, if you remember, we had a problem similar to this one. D raised to the 4th. So DO to the 4th minus DI to the 4th. Sorry for that. Okay. So let's check again the units if we're right. So let's check the units if we're right. So this one should be a unit of stress. So this should be a unit of stress. Your torque will be in Newton meter. So you convert this one to a meter, and we have this one to be a meters to the fourth. So cancel out 2 there. So Newton per meter squared. So you have a unit of Pascal. Okay? Sorry, can you calculate this one for me? Sorry for this. So what will be your stress, your shear stress? $47.7. What else? 49.1. 88. What else? What else? I'm not sure how you got this one. Probably it's the rounding off, but I got mine to be 49.1. So probably it's the rounding off if I find it okay. But this one is really a bit off. Not a bit, quite a lot off. So, if you're going to write your 2x2 tensor, so you have now 49.1, 49.1, and then you have there to be 0. Okay? So I think the others you will be able to get it now. It's quite straightforward. You have a similar problem in gearbox, where you have the power, and you have the torque, you have the shaft, you have your spur gears connecting that. Don't you have that kind of selection of procedure? Okay, please continue with the last problem.
Is that megapascal? Maurice, 它的是 megapascal 而已。I think so lah.
So by the way, the units that I got will be in megapascal. So do you have any corrections with that? This one will be in megapascal, not pascal. Okay, so just be careful. If you work on millimeters here, so you should be expecting millimeters squared here. So Newton per millimeter squared will be in megapascal. Okay, but if you're working on a meter, Newton per meter squared, that will be 8 pascals. So just be careful with your units.